Hey guys, here's another calculus video, but this time it's a run-through of one of the FRQ problems from 2005. I have a cold, so sorry if I sound disgusting. Without further ado, here's number 5 from 2005. The car is traveling on a straight road. For the following seconds, the car's velocity, v of t in meters per second, is modeled by the piecewise linear function defined by the graph above. A. Find the integral of v of t from 0 to 24. Using correct units, explain the meaning of the integral. First off, we know that the integral of a function represents the area under the curve of that function. Therefore, the integral of v of t dt from 0 to 24 is the area under the curve of v of t from values 0 to 24. The function of the graph here is drawn out as a trapezoid. This will be an easier shape to find the area of. What I'm going to do is split the trapezoid into 3 shapes, 2 triangles and 1 rectangle, and find the areas of those 3 separate shapes and simply add them up. The area of the triangle is found by 1/2 base times height. For the triangle labeled number 1, its base is 4 and its height is 20, so 1/2 times 4 times 20, which equals 40. The area of a rectangle is defined as base times height. Rectangle 2's area is 12 times 20, which is 240. And finally, figure 3, a triangle, will have an area of 1/2 times 8 times 20, aka 80. Add these all up for the integral of the function from 0 to 24, and you get 360. The integral represents how far the car has traveled between 0 seconds and 24 seconds. That distance is 360 meters. B. For each of v prime of 4 and v prime of 20, find the value or explain why it does not exist. Okay, let's re-establish the cases in which a limit does not exist. A limit won't exist when the function approaches more than one value, when the function has a vertical asymptote, or when the left-hand and right-hand limit values of a point on the function are not equal. Since the first 2 conditions don't apply, let us test for the third condition in both of our cases. For v prime of 4, we set up the limit equation as follows, plugging in a value less than 4 for the left-hand limit. The solution comes out to be 5. Plug in a value greater than 4 for the right-hand limit and we get 0. Because these 2 solutions do not match, the limit for v prime of 4 does not exist. Now for v prime of 20. Some people may get stuck at this part because they don't know what value to plug in for v of 20 since it's not labeled in the problem. But the graph is given to you so you can simply look at where t is 20 and find its corresponding v of t value. V of 20 would be 10. I chose to use the value at which t equals 16 for the left-hand limit and t equals 24 for the right-hand, since they're easily labeled. When you solve both limit problems, you get the same solution, -5/2. Therefore, v prime of 4 does not exist since its left and right-hand limits do not match, and v prime 20 is -5/2 meters per second squared. C. Write a piecewise function for a of t for the following interval. Let's get our facts straight first. V prime of 4 does not exist, as we found out in B. If we test v prime of 16's left and right-hand limits as well, we get that the 2 values do not match, and v prime of 16 also does not exist. Sweet. Therefore, we know that a of t equals some values for the following intervals. The intervals will include all values between 0 and 24, minus the ones of which v prime of t, aka a of t, does not exist. But what are the values for these intervals? Well, we already found the value of a of t from the third interval, t is greater than 16 and less than 24. We found it out in part B when we tested the left and right-hand limits of v prime of 20, or a of 20. It was -5/2. And we can look at the rate of change, or the slope of the function from 4 to 16, and see that it is 0, since the function is constant from that interval, meaning a of t is 0 for that interval. We can also look at the rate of change in the first interval, t is greater than 0 and less than 4, to find a of t. The rate of change, or slope, is 5. We use the rate of change formula one last time for this part of the question. In case you didn't know, the rate of change is found by the following formula. So for example, going back to part C, I did v of 4 minus v of 0 all over 4 minus 0, which gave me 5. Yeah? Now for this problem, in figuring out the average rate of change on this interval, we get the following equation, which will give us negative 5 over 6 meters per second squared. Finally, the mean value theorem does not apply to v on this interval because, remember, v prime of 16 does not exist, so v is not differentiable at t equals 16. The mean value theorem applies only when the function's derivative exists at all points in the interval. Okay, that's all for this video. This problem was easier than you thought, huh? The main points of this problem dealt with finding the area under the function v of t, testing limits, finding piecewise functions, and average rate of change. Check out the links in the description below for more practice problems like this one. Thank you for watching.